Hello everyone. My name's Colin Murphy and thank you all for joining for our ExactFlat webinar. We will dive right into it. This should take about half an hour. If you guys do have any questions throughout the presentation, feel free to enter them into the chat window and we can either address them at the time or we can, I'll be hanging around for a few minutes after the webinar just to answer any questions that may be posted there. All right, so let's do it. Okay, so we'll be flattening anything with ExactFlat. In this case, we will actually be flattening a couch cushion. That is my smiling face on the screen. I've been with Javelin Tech as an applications expert for a year now. Prior to that, I did design work of custom welding equipment for use in nuclear and aerospace applications. And since then, I've been here at Javelin. So what will we be covering today? We're going to start out by answering the question, what is ExactFlat? Seems like a good place to start. And after that, we'll get into an actual demonstration of how ExactFlat works. We'll go with our, we'll start with our piece creation by selecting exactly where on our part we'd like to cut. We'll also talk about assigning a specific material to this and then actually mathematically flattening this model. The goal here is to minimize sag and stretch in our part. After that, we'll be aligning our pattern. This will help us visualize kind of the assembly of the way that our pieces are going to go together. As well, it will help us if we want to put this on any sort of drawing with any sort of measurements or information like that. And finally, we'll be adding hardware and seams. These are kind of our finishing touches before we export our final product. Okay. So let's start off. What is ExactFlat? So ExactFlat is a piece of software that assists in designing, developing, prototyping, manufacturing, and providing costing information for any product that consists of composites, industrial fabrics, or even textiles. What is nice about it is that it integrates directly within your SOLIDWORKS environment as an add-in, similar to any other SOLIDWORKS add-in that you may use. And what this means is it allows you to work directly from your SOLIDWORKS model and is parametrically linked back to any design changes that you may see in your model. Okay, so the output of this is a mathematically flattened representation of your model pieces, which can then be output to a DXF file and sent to your specific cutter, whatever the cutter may be that you're using. Okay, so today the model we'll be looking at is this couch cushion. Okay, simple enough. And the output that we're going to be getting by the end will hopefully look something like this. Okay, so what we have here is obviously more than one couch cushion, but this is a flattened representation of different pieces that we've assigned throughout the process, and this also includes some hardware, some V-notches for alignment, etc., etc. Okay, so our first step here is going to be, from our solid model, is going to be creating the pieces that we're going to want to cut. Okay, so I will switch over, and here I have our solid model of our couch cushion. Okay, so if I open up my add-ins at the top, you can see that I have, all the SOLIDWORKS add-ins like simulation, inspect, and visualize, and down here at the bottom, very similarly, is ExactFlat Design Studio. So once I activate that add-in, I get a new tab in my command manager. And this tab is going to contain all of the functionality that we need to flatten, add hardware, etc. for our piece. All right, so before we get going into the actual process, I'm going to point out a couple of things that I've done here to this couch cushion. So this is a solid model. This will also work with surfaces if any of you are modeling and surfacing. Okay, but one thing that I've done is I've added a split line here to the back face, just to split this piece up. If I wanted this to be two separate pieces, this is how I would accomplish that as well. And I've taken this edge here all the way across, and I've converted it into a 3D sketch. Okay, so this 3D sketch is going to come back a little bit later. Basically, what I'm going to want to do is take this line and apply a zipper to this line to place the foam inside the couch cushion. Okay, so we can apply 3D sketches to our model. If we have individual points, we can use those for drill points or specific hardware. Or we can add lines, and we'll see how we can put in that hardware a little bit later. Okay, so let's get to making our pieces. The ExactFlat toolbar is very linear in the way that we're basically going to be working from left to right to create our DXF file. So on the very left, we have create pieces. Okay, so one thing that we can take advantage of is SOLIDWORKS selection sets. So what I've done here is I've actually saved a selection set that represents my top piece. There's this main piece, and there's also a sliver, a little tiny face along this edge. So what I'm going to do is just select here, and you can see that those two faces have been selected, and when I hit enter, our piece has been created. Notice the faces here have changed transparency, which helps me know which pieces I've created. I can select the bottom face, hit enter, and I want this full wrap around the front to all be one piece. So what I'm going to do is I'm going to go and just select faces one by one around our part and hit enter. That piece is made, and now I can select these 6. They're all going to be the same piece, and hit enter. So now all of our faces have been selected, all of our pieces have been created. In this case, we're just going to use 4. And notice here in our piece manager on the left side of the screen that we have the pieces being named A, B, C, and D. Now what we can do, we can type in new names of our pieces here as we create them if we want, or, and probably more commonly in our ExactFlat settings, we can set up exactly how we would want these pieces to be named. Maybe it's going to be a project number -A and then -B, -C, -D. Or maybe we want it numbered 1, 2, 3, 4. Okay, it's really up to you how you're going to want these pieces to be named. But for this case, we will just go with our letters. So once I say OK, we get a new item in our feature tree. So just like any other of our SOLIDWORKS features, we can go back in and we can edit this if we want to change pieces or add or subtract, or if we made a mistake, say. Okay. If you're familiar with SOLIDWORKS surfacing, you might recognize these blue lines surrounding faces. Okay, so these blue lines indicate surfaces that are not knit. So in this case, it's showing us the division between our different pieces. So we can it's a nice visual feedback here, telling us where exactly our pieces are being trimmed relative to each other. Okay. And that's how we create our pieces. All right, so next we'll talk about applying a material and as well how we're going to flatten this model. Okay, and we'll do that through the use of the ExactFlat flattener, okay, which you can see a picture of here. All right, so if we go back up to our ExactFlat toolbar, if we're moving from left to right, the second button here is Convert to ExactFlat. So when we press this, what's going to happen is this is going to create a preliminary mesh for each piece. It's going to create pattern data for each piece. And once it's done this, it's going to pop up and it's going to allow us to actually select a material for all of these pieces. Great. So you can see a list of our pieces here on the left, A through D. Okay, and we also have a list of different materials. Okay, so we can add our own custom materials here for use with our pieces with specific material properties and data within them, such as the size of our cutting sheet, for instance. For now, I'm just going to be using some of the sample data that we have. So I'll make this a brushed warp knit. Notice that this has applied to all of the pieces because I had them all selected. If I only selected one piece, I can then apply different materials to different pieces if I want to. But for simplicity's sake here, we're just going to leave them all as the same material. So I'll say OK, and now it's been converted into an ExactFlat part. Okay, notice the pretty significant color change here. Okay, this is dictated by properties that we have set when we create those custom materials. Okay, obviously we don't want a blue couch cushion, but it's just a representation of our model based on the color that we input for our materials. Okay. So now moving left to right, we have our flattener. So when we open up our flattener, what we're going to get is a nice visual representation of our model and the way that it's been meshed. Okay? So we can go piece by piece, see a 3D and a 2D on the right here representation. Okay? These colors that you see are an indication of the level of stretch or sag in the model. Okay, so you can adjust these colors to appear for specific amounts of stretch and sag. For instance, if anything above a 5% sag is unacceptable, then you can choose to only have sag above that level showing, say, in red. Then you know anywhere with red coloring is going to be a sag that's unacceptable based on your parameters. Okay, if I select all of these pieces, we can take a look at our mesh, and it doesn't look ideal in this case. So we have a couple options. We can create a standard remesh, which is going to assign triangles based on sizing that we've specified in our ExactFlat options. Or we can do an adaptive remesh, which is going to concentrate triangles near edges, etc., but will result in a slightly longer optimization time. So in this case, let's just do a remesh. And as that's happening, we can see the model of remeshing, and it's complete. So that mesh looks a little bit better for us. Okay. And now all we need to do is optimize. So this optimization goes through all of our pieces, and it's going to slowly work out that stretch and sag. You can kind of see how these colors are changing. We've lost most of the red that we had before. Okay. We have a very good visual of where exactly our stretch and our sag are going to be. In this case, it's going to be fractions of a percent in this case, based on the colors that we have. But we can go piece by piece as well and see. Okay. So very little stretch or sag in either of these pieces. A little bit here in the corners, and very little on this one as well. Okay, so normally this process doesn't take too long. We'll give it maybe a minute or so to keep running through the optimization. Okay, we can also at any point stop this optimization forward with the shape that we have. So between 75 and 100%, it may not make a significant difference in the geometry, but usually it doesn't take too long to just let it run out to the full 100%. Okay, so we could let this run. When I've done this model in the past, it normally takes a couple minutes to run through, but just to save some time here, I'm going to stop. Okay, so we'll accept it in this state that it is now, and we can say OK. And now ExactFlat is going to rebuild edge reference. So what it means by edge references is where these different pieces are contacting each other, and these are going to be very important when we're adding in seams a little bit later. So we'll see how we can use those edge references. Okay, great. So now that our material is assigned and our part is flattened, we're going to align our pattern. Okay, so this will help us visualize how this part may go together, and it can also be useful in different engineering drawings. So in this case, this is the output that we're going to want. Those are all of our flattened pieces, and we're going to align them next to each other based on where they assemble or where those edges contact. So if we go back to our part, moving left to right on our toolbar, after flattener is our view pattern. So when I view this pattern, we get a 2D representation here of all of our pieces. Okay, so we need to move those pieces. The first thing I'll do is I will find the top edge of this piece, and this is just going to align this piece so that this edge I'm selecting is horizontal and on top. Okay. And then after this, we can use our find tool to find matching edges to this one. So if I click and hold on this edge, it's going to find the piece that matches to that edge, and it's going to place it 4 inches away. Similarly, I can select this edge, and we'll get our piece preview and placed above it. And then finally, I can select this edge, and because of those edge references, it's going to place this piece above. Say OK. And now our pattern is done. So this is a view that we can export and place on drawings, etc., if we would like to. Okay, and our final step here is going to be adding in seams and hardware. Okay, so just kind of the finishing touches. So we can add things like seams, hems, raw edges, or a bound edge. As well, we can add hardware, including custom hardware that we put in ourselves. We can add notches, which we will, and we can add drill points as well. And we can specify grain lines, which for aesthetics would be pretty important here for a couch cushion. So we'll put a couple of those in as well. Okay, so all of our seams and edges are here, and our hardware is all here. So if I go back and view my model, which I can do here, remember we had this line that I wanted to designate as a zipper. So what I need to do is select hardware, and it's asking me to select a sketch. So based on whether or not your sketch has a line in it or just sketch points in it, it's going to give us some different options for hardware. In this case, it's a line. You can see it's showing me my line length as well. And if I select hardware, I can select my zipper here. So say this is going to be a zipper, and I'm going to map it to this piece so that it knows which piece the zipper is being placed on. Say OK. And the color that I chose for zippers was red, so we can now see that red zipper has been placed. Okay. We can also extract costing information for this zipper based on the overall length. Say we have a cost per unit length for a zipper, we can extract that information as well. If we have hardware that's been specified by individual points, say a number of buttons, we can also extract costing information based on the number of buttons and the cost per button. Okay, let's go back to our pattern, and you can see that on this top piece, that zipper has been placed on our flattened model. So we can either place our hardware here in our 2D view, or we can go in and place it in our 3D view. Maybe that's a little bit easier to dimension and place, and then it will propagate forward into our 2D view. Next, I'm going to add some seams. So when we had our edge references before, that allows us to do, when I select our seam, let's do this edge here. Notice that it's going to pick up on the mating edge from the corresponding part and apply that seam to that edge as well. So here I can select, maybe I want a 1/2 inch pinch as well. This list is customizable. You can add in your own. We'll do a 1/2 inch pinch, and I'm going to continue selecting edges all the way across this part. Note that as I select them, it's also placing that on the matching part. And there you go, our seam's been placed. So I say OK, and it's going to add material to both pieces. Okay, note we can add labels to this if we want. I will add one more here. Let's do our bottom. Okay, so in much a similar way. Okay, and what we can add are notches. So we want alignment notches. Let's add in a 1/4 inch V notch here, and we'll put 10 of them. Okay, so there are 10 notches placed along our seam. If we want to go back and edit a seam, say I want these on this upper seam as well, I can just click one of the edges that belong to that seam and press seam. It will gather all the related edges, and now we can go in and in this case add in 10 alignment notches. Okay, just like that. Now on a couch, aesthetics are pretty important, so we may want to specify a grain line for some of these pieces when we're running it through. Okay, so in this case, I can open up a sketch and draw a line. Just make it a vertical line here. And I'm going to open up a sketch, maybe here. And that looks good. Okay, and now I can select grain lines. So this is going to work very similar to the way that we applied this zipper. I can select the sketch, and I can select the pieces I'd like that grain line to be mapped to, which are going to be these two, and confirm. Okay, so we get a visual indicator here with this red arrow of the direction of our grain line and the pieces that it's on. So in a similar way, we can add a grain line, say, for instance, onto these pieces, and confirm. And we're going to get a grain line on these pieces now. And we'll see how that works with our when we bring this into our marker. Okay. I will add one more hem, or one hem here. So let's go ahead and maybe I want to pick these edges. Okay, I don't really want an alignment here, just for a hem. And let's make this a 12 millimeter hem, say. Okay, looks like I missed an edge here. We can pick and move that up twice. Okay, so our hem's added. Okay, so we can keep going here and we can add in different hardware, different drill points, different markings, seams, hems, as many as we want. Okay, but for the purposes of this, we'll say that this is fine. Okay, so this is good enough for us. So let's go into our marker view. Again, a left to right. Last one here is markers. Okay, so you can see a preview of all of our forces on our marker. I'm going to delete those. And let's say for each of these, select these, and I want to increase the quantity here. Let's make 20 of these. Let's try this again. Okay, there you go. So we have 20 of each. We can select, we can see our quantity of 20 here. And I'm going to make sure here, this is all information that you can specify within your material properties, but I want to make sure that my lay rule here is just going to be two-way so that it respects that grain direction. And when I place these, instead of left to right, I'm going to do a box packing here. Okay, so now when we select all of these and bring them all in, you can see that we have all of our pieces that have been placed respecting their grain direction, and they've been placed somewhat to maximize the usage of our material. Okay, there is a nesting option here. Okay, that's part of ExactFlat Pro. But for now, we'll just assume that this nesting is okay. We don't have too much material wastage. And that means that we're ready to export. So if I export this, we have a bunch of options of layer names and what we want to assign to each layer and the color that we want to be assigned to each layer. So in this case, I've set up just a custom profile for me, but this profile is going to be different depending on the cutter you're using. The layer name that you want to use, a lot of them are cut me or pen me. So depending on the cutter you use, you'll be setting up a different profile. Okay, there are some in here like an Eastman or etc. But for now, we'll just use this one that I've set up. We say export. Say cushion markers. And now our marker's been created. So let's go ahead and check it out. Okay, so you can see that we have all of our information. We have our piece names, which have come through, which is something we can toggle on or off. We have our alignment or notch annotations here, as well our line for our zipper, and all of our pieces respecting the grain direction. Okay, so that's the process. It's quick, it's simple. If you do have any questions here about this, then feel free to type them into the chat box now. I'd be happy to answer them. I'll be sticking around for a little bit of time. As well, if you'd like a more in-depth in-depth demonstration of the software, perhaps using one of your own part files to see how it could work for you, please don't hesitate to get in contact with us here at Javelin. That's definitely something that we could do for you guys. So thank you all for your time and for attending. And if you do have any questions, then by all means feel free to type them into the chat box, and I'll be hanging around for another 5 or 10 minutes to answer them.